what we can actually do now with AI is new. Our capabilities of what we can build, what we can process, and its portability is brand new. But the ideas are actually very old. We coined the term artificial intelligence in 1956. John McCarthy did.
Around like 2014, 2015, you start getting this explosion in machine learning, which is a subset of artificial intelligence. And so now all these devices that are out there are seen not just as a way to enable some kind of effect for an end user somewhere, but as a source of data that, when aggregated with 100 million other similar things, creates an effect, creates information about the world we could not have possibly had before. And that then can create experiences we could not have possibly had before. That then leads into kind of the current AI boom. And so there was this AI winter for decades that was created by essentially an AI bubble in the late 70s that was funded by the US Department of Defense. They had poured all this money into AI in the late 70s in the expectation that it was going to produce amazing effects that were going to let us outcompete the Russians in every possible way. And it didn't happen. And the disappointment from that lasted like 20 years. And disappointment was actually coupled with lack of funding. So all these people that have been working on all this stuff quietly because they believed in it, suddenly were able to now utilize all the work that they've been doing for 20 years and make it actually worthwhile. And the world that we find ourselves in right now is this world where artificial intelligence in various different forms, based on incredible amounts of data created by all of these connected devices out in the world, is now applied to our lives through all of these different kinds of terminal devices, through TVs, through laptops, through phones, through tablets, through cars, all these kinds of devices. And everything now, and that's, I'd argue, like where we are right now. The next step is not very, and in some ways it's very clear. There's going to be just a lot more AI because that's actually how you make sense of all the data that's out there. That's how you create value. That's how, instead of like an individual human being, data scientist, data mining, you have an AI that is that's generating all the value. And that's just going to proliferate. But at the same time, that's going to then drive the desire for there to be all these different devices and for there to be all these different new experiences of these devices. You look at the new, announced a couple days ago, Google Eclipse camera. So it has no screen, and what it does, and it's designed, it has an AI in it that's designed to recognize interestingness. Like that's literally the way that it works, is that you set it somewhere and it sits and watches things, and it has a model of what it thinks is interesting, and then it will photograph that. Then you go through the results and you tell it what you think is interesting, and it modifies its model of what it thinks is interesting based on what it thinks you think is interesting. And which represents a fundamentally different relationship with all these technologies than we've ever had before. And it represents a potential, but also a kind of a incomprehensible craziness to experiences that we've never had to experience before. And moreover, we don't have great tools for designing those experiences yet. So the next challenge is going to be much like designing, much like we've spent a decade working on the design of tools for hardware, designing the tools for AI and the designing for tools for AI and hardware together.
We're kind of like learning what it means to be a designer in a kind of world of machine intelligence. And a lot of the stuff that we're kind of like maybe like borrowing or stealing is coming from the world of service design. and also like community design in a way, and participatory design, in that a lot of it is about kind of problem framing. So you have this kind of like new take on some of the tropes of user-centered design or participatory design and service design that start to play out in the system design of systems that have a significant kind of machine learning or machine intelligence component.
The most magnificent thing about machine learning and AI is that it can take big data, contextualize it, and whereas in the past where we've had to instruct computers on specific data sets and tell the computer how to use it, the computer and the algorithms are now able to be more intelligently understand how to accurately use the data in flexible ways and in adaptive ways and in a real-time context, as opposed to just locked Encarta CD-ROMs. This is a dynamic, free-flowing, ever-evolving and ever-refining system that for each bit of input, for each Google search that occurs globally, the AI of Google gets that little bit more intelligent, and that's extraordinary.
Basically, any work that has any repetitive component to it at all, lawyers, law, accounting, any kind of work is going to be replaced by machines very soon. Or a significant portion of it. Much in the same way that you don't replace all furniture makers with a automated furniture factory. There's still some people who make some furniture, but it's a very small amount and it's very niche, and it's only about one kind of work. So I think that is going to have enormous implications on society and the world at large. We can talk about why, essentially, what are all those people going to do with, how are they going to get health insurance? How are they going to pay their rent? What's going to happen when they have all this time on their hands? There's this utopian vision that you see in the early kind of automation stuff from the late 19th, early 20th century, where it's essentially thinking that we're just going to have all this leisure time, we're all just going to be playing around and writing poetry. But that's actually not what people do. People become anxious, people become angry, people become frustrated when there isn't an obvious thing that they're trying to accomplish in their life. So there's going to be this deep need for people to have meaning in their life, which then is going to have all these giant social repercussions. And I think we're starting to see some of that already, or maybe I'm just biased because of recent political events.
The things that machines are great at, numbers, working at speeds that humans cannot, creating and sort of evaluating, billions of possibilities in very short amounts of time. We kind of do the same sort of thing, but in a very instinctive way. We don't quite know how. If you smush those things together, what do you get?
We have this really fundamental choice right now around also what people do. And that goes to this kind of core question about what are machines good at and what are people good at? What is code good at and what are humans good at? And there's a danger, unless we stop and ask those questions, which means understanding the seams and the way those things work again, that we'll just we'll make all kinds of unthinking decisions about stuff that should be automated. Which could have all kinds of problematic effects.
I see algorithms that are just in the last year that are adopting the painting styles of some painter and applying that to a photograph and coming up with some things that are really pleasing. Same with music, same with generating music. And then you could say, well, if the generativeness is being done by a neural network, maybe the judging is then being done by the human. So maybe, we keep in my college religion courses, we had this notion of the God of the gaps, which is If your notion of God is the things that you don't understand, then you say, well, what causes the seasons? Well, God causes the seasons. And then you figure out, well, actually it has more to do with the tilt of the earth. Well, okay, that wasn't God, but the thing that makes the buds come up in the spring, like that's God. Because, well, it turns out it's bad. Well, the thing, like, so your notion of God keeps getting smaller and smaller the more you learn about the world. So I feel like we sort of have the same God of the gaps problem with AI, where we say, well, what is the unique providence of humans? Like, is it the generation of things that are visually pleasing? Well, maybe not. Maybe not. Is it the judgment of the things that are visually pleasing? Well, maybe not. Is it the so we keep getting like sort of smaller and smaller in terms of the providence of humans, in terms of their uniqueness. I guess I still believe that we have a long way to go in terms of general AI. I feel like the things that humans could do most uniquely are ask good questions, find new connections between things, like invention. And the closer we get to things that feel like they're pattern, like there is some patternness to them, like that, then you can get enough data to teach an algorithm to do those things. Because you can build a neural net with almost anything that has labeled data. If there's a history, if there's a heritage for anything, you can, if you have a set of decisions that doctors have made, decisions that dentists have made, decisions that farmers have made, decisions that designers have made, if there's any residue of those decisions that can be labeled, then you can train a neural network on it. So the domain of humans is the things that for which there hasn't been a heritage of decisions that have been made about those things. So that's like the things that for which there aren't yet patterns. So I think that's the unique place for humans to focus. But I also don't believe that I think people who talk about jobs being taken away are being alarmist for, maybe to sell newspapers or books or something. But I think most of the things that getting automated away are tasks, which has been happening for a long time. Spell checking and other sort of tasks. And most of the time, those things would be better cast. Those services would be better cast as tools rather than as replacements. And so I think we'll all have this flourishing and proliferation of incredible tools and sometimes mediocre tools, but many, many, many new tools in order to help us do what we do. And I hope we adopt those tools, for our sake and the sake of drudgery that we don't want to be doing. We want as many tools as possible. Like, tools are good.
It's in the same way that we really didn't know what the power of the internet would be. We did not know that so many jobs would change and alter as the result of the internet. And from a peculiar position of being present when the internet was a present and active user in that early internet, it gives us this really weird perspective, because at first it felt like just being in this strange geeky club. At first, when I initially used email and tried searching for something on Lycos or Google, it felt like this was restricted to just geeky types. And now, in the same respect, looking at AI, we've got some ideas. Some of the geeky guys, like Elon Musk, is a good example. He's got ideas of where it could go, and recognizes on a mass global level where AI will take jobs, where AI will evolve. But at the same time, we're just clueless. And it's really exciting, again, to just realize we're at this fork in the road.
The promise of a superbrain is that ultimate authority, actually. And that if an AI tells us that we need to do that, maybe we'll believe it and maybe we'll take action. And I see the same scenario playing out with Climate change, perhaps, hopefully. Again, one of these super complex, interconnected problems, much more complex than the London housing crisis. But one of these things which requires global cooperation and participation, something which we haven't been able to orchestrate, but some kind of super brain that can model that and give you an answer on a piece of paper. It sort of sounds like Douglas Adams, 42, here it is, off you go, solve climate change. So in a way, it might not be that it gives us a new idea, but it might be that we decide to listen to it because of its divine authority. I see it almost like creating a new God to worship to.
Extends from Donna Haraway's companion species Maratheta, when she talks about kind of living alongside skilled animals, or living alongside species that have skills and motivations and behavior and experience that are not human, but we live together, and together we are this kind of amazing team for doing something. Personally, I sort of like to think of machine intelligence in the way that you might talk about emotional intelligence or bodily intelligence or physical intelligence. It's a flavor of intelligence in a way. It's not, from my point of view, then that sort of makes it seem like it's not replicating or imitating or aping human intelligence. You are deliberately employing the machines to not think like you. You want the machines to be doing the things that humans cannot do, whether that's in the realm of machine perception. What can different cameras see? Different spectra, different sensors, whatever it might be, different inputs that humans don't have. There are senses we just don't have. Different types of reasoning and cognition, particularly in terms of speed and power of crunching numbers and coming up with scenarios, creating models, running those models. Different outputs, where we speak and write and draw. What can machines do that humans can't do?
Negroponte suggests, and other people suggest, Cedric Price also suggests that maybe the computer and the human together are coupled, different than the sum of the parts, other than the sum of the parts, weirder. Maybe the computer pushes back on the designer. John Fraser said, the very least you would expect of a system is that any good system is that it would kick you back. I really like that. We don't expect computers to kick us back. It's a coupling. It's what the human does and what the computer does. They come together and something totally new forms. Not one is over the other. And there's a lot of fear around that. I mean, consider HAL 9000. That's what we feel. We don't want to see the room takeover or Minority Report. I mean, there are a bazillion different surveillance AI cliches that we use now to talk about that fear of the computer getting a little too uppity. Yeah. But what if it did?
Garry Kasparov famously went up against IBM's Big Blue. Garry Kasparov, chess grandmaster, went up against the IBM machine and was beaten. It was kind of, the headlines were about, human defeated at chess, humans are on their way out, all the rest of it, without really sort of understanding, kind of how Big Blue had done it, very much through brute force. Kasparov kind of licked his wounds and kind of came back fighting, and in fact sort of flipped it on its head and said, actually, what we'll create a new form of chess, where we have teams of humans and machines playing against each other. So it has various names, but the one that sort of I guess I seized upon, but just with the romance of it, I suppose, was Centaur chess, alluding to kind of the mythological creature which was half horse and half man. So this idea of kind of Centaur teams where there are human intelligences and machine intelligences working together against another team of human intelligences and machine intelligences, and the outcome was about kind of the best synthesis of all of those things. The brute force of the machine intelligences, the speed at which they can consider all of the options and play out all of the possible outcomes, and sort of the humans choosing and surprising and almost like using more of the social intelligence to kind of, more of the psychology, if you like, against their human opponents. And that just sort of seemed like a fascinating pattern or a possibility for the near future, where you would sort of have the best of both worlds and sort of very much focus the machine intelligence on the things that machines are great at, numbers, working at speeds that humans cannot, creating and sort of evaluating, billions of possibilities in very short amounts of time. We kind of do the same sort of thing, but in a very instinctive way. We don't quite know how. If you smush those things together, what do you get? If you have a Centaur team adopting that pattern from the competitive chess world, addressing other problems or other areas, what would happen?
One of the other notions about machine learning and the idea of artificial intelligence is that, like a lot of other technologies, there comes a point when someone again has to make sense of it and say, do we really want, okay, we can make this capacity, but it's great that we can do it, but do we really want that thing? And looking at augmented reality, where there's sort of a human side to it and a machine side, and they're sort of working in concert, is so much more appealing, because there's still this sense of that the purpose is still the person, it's not the technology. And keeping the balance of that right is really, really fascinating.
I think what's really important is that designing that system of cooperation is, we don't have a name for that discipline yet. We don't even have a vocabulary for that phenomenon yet, by which human and machine collaboration outperforms either human results or machine results. But we know it now. It's probably been, I would say, 5 years or so that enough evidence has come in on this. But the question is, who is going to design those systems of interaction? What is their background even? Who are the designers who are going to work with the scientists and technologists who are building black boxes to make sure that they are collaborative instead of executive? I think, if you were going to design a Bauhaus for the 21st century, that would be the priority, is understanding, let's say, black boxness as a material that designers have to be able to work with.
In order to make sure that machine learning and AI becomes something that is useful and meaningful to people, I think we'll have to make sure that we can start playing with it more. Not even the people who are designing these systems know how they work. There's an incredible amount of ambiguity and mystery in how they work, and that is extraordinarily problematic. Not only are these systems being talked about sort of as things that are going to run our lives and run our cities and run our infrastructures and our homes, but they're things that we don't fully understand yet. So I think there is a coming wave of problems with AI and machine learning, which we haven't really uncovered yet.
So what I want to do is I want to lower the barrier so that a novelist who wants to create a machine learning system that they use to generate some aspect of their creative work doesn't have to learn how to be a computer scientist first. Essentially, the tools of AI right now are text editors and compilers and data sets, which are really abstract. and to reduce that abstraction down to something that people can tangibly use, especially people who may not have come from that background.
They're not working in human time, they're working in machine time. So being able to kind of like, just like you would need like a high-speed camera to understand, at the dawn of understanding fluid dynamics, right? You were almost inventing high-speed photography in order to understand what was happening in aerodynamics and fluid dynamics at the turn of the 20th century. We're also kind of like having to invent the tools to understand what we're building at the time we're building it right now. I think that's very, very interesting, and I don't think it's the same thing as like throwing your hands up and saying, "Oh, it's a black box," and that's not the responsible approach, and it's certainly not the approach by the engineers and the computer scientists that I've encountered. They are sort of very driven by understanding how to make this stuff legible and useful and a material that can be worked with by as many people as possible. I don't think it's true that the people who are involved in working on these things don't know how they work. I think they know how they work, they know the principles that they're working by. That doesn't mean that it can't surprise you. It's a different thing. I fully accept like using terms like create and dream and all of those sorts of things they're shorthand. I'm not trying to suggest anything or claim anything on behalf of the machines. I don't think that they are creating anything that delights humans in the way that other humans can create things that delight other humans.
I think this idea of authorship is going to be a really interesting thing for us to tackle in the near future. As we think about artificial intelligence and things that can be more dynamic and responsive, there's an opportunity to tailor to an individual, which is really powerful, but it also takes away potentially from the authorship. So there's an interesting argument and discussion that's been happening recently around, especially in the music space, around algorithmic music, where if you could feed a machine learning neural net all of the corpus of various forms of music, you could just press a button and generate new Bach, whatever it would be. And people have been experimenting with this, and many music people who study music are basically saying this seems like it was a lost score. It follows all the rules set, but is that all there is? Is music just a formal analysis of rules that are then played back and generated? And is that fulfilling the needs that we have as humans for music? And I think what I would argue is you can actually do that. You can create an incredible, very powerful music machine that could generate all of the formal attributes of music you'd want to hear and have endless music, new music all the time. But it would be missing a few other things, and that's mostly cultural context and shared kind of human connection. And the human connection both between you and understanding that there was a human author, which I think may be an antiquated thing. That may be something that's meaningful to me, but isn't necessarily meaningful to humans in the future. I don't know. Interesting question. Those are going to be interesting topics as these algorithms and machines get more advanced. And, I mean, it ties into many of the ethical questions as well about once they become autonomous, how they differ. And I think they do differ in very meaningful ways, but it'll be harder and harder to distinguish, which means we have to be more deeply educated and informed to even be having a conversation about that.
We're just starting to wrap our heads around it. What's really interesting here right now is that actually the science of it is moving almost faster than we can keep up with as artists. And I've had this conversation with Kyle McDonald. It's also kind of almost painfully for us more interesting than our own efforts with it. I think like a really astute computer scientist right now who's working with machine learning with barely a hint of a conceptual turn could deturn what they're working on and represent it as conceptual art and be right there, like in terms of like the conversation in the arts but That rarely happens. But in some cases, it doesn't take much to kind of cock one's head 5 degrees and look at the stuff that's coming out of the research labs right now in machine learning every day or every week, and see it also as kind of profoundly interesting conceptual art that often is more interesting than what we're doing right now. It's a kind of a moment of reflection for the artists. It's very hard for us to keep up with the pace of how quickly that's evolving at this moment right now.
They create these symphonies and then have those performed. Then you listen to that music and some looks a little bit simple, but others, they're very complex, articulated, deep. And sometimes actually, people get moved by the beauty of that music until they know it was made by a machine, right? So if it's a human that does that, then you associate that to a spark of genius, something which is rare, something which is valuable, something which is unique, something which we are trained to prize. It is indistinguishable from, the production of a human. But once you connect it, you rationalize it, you think, that part puts me off. I don't like it anymore. We are in charge of deciding what's valuable or not. And we may well decide that this is valuable just because it's done by another, say, participant in our race, not by a machine.
Stuart Russell at Stanford, who's writing about and forming working groups around the possible implications of artificial intelligence and intelligence explosion, and what might happen if that were to get into the wrong hands or out of control or whatnot. And these kinds of preemptive ethical questions, I think, are being played out right now. I mean, his famous example, which is he says currently the technologies exist on the table. They haven't been put together yet to develop a swarm of 10,000 exploding drones that we could just throw at New York City and bring the whole thing to a stop. And they would be automatically seeking people. And if you think about it, we have that technology of computer vision, of flight, and of weaponry available to anyone. And how where do technologists fit? Where's their responsibility in that triangle? And I think, I don't know where I sit on that. I find the precautionary principle to be a limiting one when we don't know the territory enough, and we need to provide spaces for research, but also anticipate the misuse of technologies.
Putting immense power into the hands of a very small minority is a new thing for human civilization. It's probably one of the most dangerous things that we face, whether it's mass shootings or nuclear warfare or biological warfare. All of a sudden, very few actors can do very large things. So I think it's important for us to confront that. It's important for us to try to tackle and handle it. But it's also important for us to not lock up and become a totalitarian, horrible place to exist. So I optimistically come back to some of these ideas of data visualization, transparency, to have a discourse and to try to, I think the other thing we're going to struggle with is discourse, and human discourse takes place at glacial speed as compared to, a neural net spinning up a way to spin past everything. So it's easy to go dystopic pretty quickly, but there are also a lot of really practical realities. Those machine learning algorithms are running on hardware that exists in a box somewhere that somebody's controlling and managing. And at least for now, we still create and manage these systems as people and as decision makers. So I think government and policy being so far behind is one of the most dangerous things, because we need to lift that into some speed that slightly resembles the speed that corporations and technology companies are having about how to handle these things, or at least get a better conversation between those two entities with a lot of transparency and accountability to say, okay, how are we going to handle this? And let's get some smart thinkers focused again on people, because are we building these systems for humans, or are we building them for themselves? And if we're building them for themselves, let's launch them into deep space so that they can provide some value elsewhere.
It's exciting. It's frightening. It's got all the right characteristics for a disaster movie. as well as the right kind of makeup for helping us as human beings get over this peculiar stage that we're currently in. And so I think that it's inevitable that there's going to be major stumbling blocks. What's extraordinary is that the stories that we celebrate and exchange, such as Terminator and all the doom and gloom and collective warnings that we share amongst ourselves, I think we'll be faced with some serious power struggles and conflicts that affect our lives as a result. And, you can already see that in terms of the political development of the way that the internet is being treated and the attempts to control the internet are having a huge effect on people. AI is just going to exacerbate this situation and bring a new, more critical contender into the mix that no one quite understands what it is yet.
Consciousness is one of the most cited, researched, but least known topic of humankind. When you look at literature or scientific studies, we still cannot figure out where consciousness exists, whether it's in the body, in the brain, or somewhere else. So we still haven't figured out what intelligence is as a matter. So yet to understand giving another being consciousness, and so making machines intelligent. What is intelligence anyway in the first place? So I think this is the scary part, that we don't even know our own consciousness and our own intelligence. And how that will translate to a machine is one big question. But me being optimistic about artificial intelligence for two reasons. One is, I think it's really important to have another specimen as a machine that is as intelligent as humans, just for us to understand our insignificance in this planet, in this universe. So looking from that part, that doesn't mean a destruction scenario in the near future, but how can we coexist with other things? The moment we can empathize coexisting with another, intelligent being, probably that will also allow us to understand nature more. That will allow us to look back and try to fix all the things we've done wrong. So I'm optimistic for that very reason. But on the other hand, this will take years. The predicted machine intelligence is based on the surveys, futurists, scientists, and AI experts. It's the 2030s and 2040s. This might change, but this is what they are talking now. So by that time, we will have an idea of how we utilize artificial intelligence in the form of a tool, in the form of a service, in the form of a car. But how we're gonna really exist together is big unknown. That requires a big brainstorm about social constructs and how they can live together, and ethics. Like what are the ethics? And the reason I'm optimistic, but also optimistic because we need to understand our insignificance. The AI that speaks language trained by the literature, the beautiful literature of humankind, still carries cultural biases. That's all the studies are showing. And when they start speaking, they put a she before nurse. They put a he before a doctor. So, and this is not an intentional thing, but when you look at literature, those nuances there, it's ingrained in culture. So how can we let something to be created or create something that is perfect while we are being so imperfect? So I think it's the process of artificial intelligence or creation of artificial intelligence will allow us to look ourselves more than the machine itself, to understand our intrinsics, understand our dynamics, understand our biases, understand our faults and beauties. So I think it's really interesting times that we will be going through this philosophical level of understanding humankind and intelligence, and also understanding what machine can do, which is more fascinating, obviously. It's really exciting things.
Interaction designers currently are worried by the growth of machine intelligence, artificial intelligence and so on, Internet of Things. Because previously, of course, our interest has been in the interaction between the human and the machine, the human and the device or the digital system. And if the digital devices are talking to each other and learning from their experience, the human is actually kind of cut out of the system. In a sense, that's appalling, but in a sense also, I kind of like the idea that there's a kind of set of there's a universe of digital artifacts which have their own distance. They're not going to ingratiate. They're not going to be begging us for their attention, for us to buy things, as it were. They're just out there. And we can continue with our life, a little facilitated by them, but not constantly bothered by them.
One of the changes that's gone on in interaction design recently, and you can hear a hint of, to my idea, misguided ML, machine learning behind that, is what I'm seeing as sort of the death of intentionality. We're trying more and more to remove the part where the person decides that they want something to happen and then takes an action to indicate that they want it to happen. We're removing the button, in other words, right? You can see that with all the voice-activated things. You can see it with the phones as they gradually become sleeker and sleeker. We don't want to have to worry about that moment where you decided you wanted something and took action and did it.
There's this sort of confusion about who's controlling what. It's this sort of intangibility that is one of the fundamental difficulties with understanding things. I think we do understand things when we can reach out and touch them. So I'm a big advocate of making things tangible, even if you have to add motors to give you a click, to push on you or make things physical.
You know, I think one of the strangest aspects of the systems that we've built, the systems that we are building, is that they don't have, they're not actually designed for human interaction. In part because how would we even speak to them? You know, and there's this broad question of how to build AI, which is inscrutable, right? That is its nature. It's, you know, one of the only ways in which I would say that AI is similar to the human brain is that it's inscrutable. I don't think that they are the same thing at all. They don't work the same way. They don't do the same thing, but they are both inscrutable. The difference is that the human brain has a whole bunch of systems that have evolved for access and engagement with other humans. You know, we have speech, we have emotions, we have self-reflection, and we don't have those things with AI. And I think some of the most interesting work that I see happening in the space is what's called human-in-the-loop computation. And human-in-the-loop means figuring out how to build systems of machine learning and AI, whatever we mean when we say AI, to build systems of AI such that there is a way for humans to have engagement and input into the decisions as they're being made. Now, that's never going to happen on Wall Street because it all needs to happen faster than it happens anywhere else, and the minute you put humans into that, it slows down by magnitudes, orders of magnitude. But not all systems are like that, and not all systems prioritize speed.
I mean, it does feel like interfaces are the last bastion of hope for trying to create a method for humans to understand and meaningfully interface with these advanced algorithms and artificial intelligence. There's a way to create summaries and reports that can be closer to accuracy. And one of the things I've always been interested with data visualization is the ability to drill down into the details and see things kind of at a microscopic level, but then also quickly pull out and see the global kind of the forest in addition to the trees. So interface, I think, will help to provide that. It's going to become increasingly complex because those systems are so complex and so self-generative, the kind of recurring nature of things. But I think it's really if you think of the future of kind of data science and artistry as a conductor of these algorithms and AIs, then those interfaces are really your tools. They're the only way to make a meaningful creation. So in a certain way, like the medium is, it is that tool set. It is all fundamentally about the ways that you interact and interface with those technologies.
The new design challenge that AI brings is, what is your instructional role in this AI that supposedly is going to help you make decisions? How can you know when it's unsure, and how can you start to feed it examples of positive behavior and sort of slap its wrist when it's close but not exactly right? I think that the most important sort of design challenge for the future with an AI future is this one of sort of shared mental models of like, how do you design a dashboard, an interface, an interaction that shows you what it sees and how confident it is of what it sees, and allows you to train and influence that. Gil at Toyota believes that an AI that helps you drive should be like a father teaching his kid how to golf. Like, you wrap your arms around them, you sort of, their hand is on the stick and so is your hand on the club, and like you're guiding them and showing them, but then your hands are off, and you're sort of there as a guardian angel. And the head of Google was like, people shouldn't be there. What do you mean steering wheels? We shouldn't have steering wheels in cars. Like, there shouldn't be, we can completely go from autonomous driving mode 1, which is just help you not crash into people that are crossing the road in front of you, which is like in cars today, to autonomous driving mode 5, which is you get in, you fall asleep, and you arrive at your destination. So it's sort of a different way of viewing AI. Like, do you want to be hands off and have all the decisions made for you, or do you want to have this as something that can collaborate and corroborate and work with you as sort of a side-by-side tool?
We have to really watch what we do with computers so that they're, I don't know what the right words are, ethical, humane, controlled somehow. I don't know what the right word is. That they'll be open and we can see what they're doing. We can understand what they're doing. We can shut them off if we need to. And I don't think we do enough of that. And the AI people want to drive our cars for us. And I'm really nervous about that.
Synthetic biology is a form of engineering, basically. And what's different about it from traditional genetic engineering, if we can say it's traditional, is that genetic engineering has been done in the past by biologists. And around the turn of this century, people like Drew Endy, who's a civil engineer, came in and said, well, why don't we actually use engineering strategies to make biology more predictable and standardizable and make it into a true engineering discipline. And by doing that, we can make biology better, we can make it easier to engineer. And that's how I got interested from a design perspective, was suddenly listening to what I just saw as scientists talking about designing biology. And they were talking about making it into a kind of a rational material system. And they were using metaphors from computer science and things like abstraction as a way to actually talk about DNA as a programming code to be able to make stuff. And the whole point was that it was going to be really easy to do. So this was around 2008 that I first learned about it. And it was going to be like plug and play parts and anyone would be able to design anything. And that's when I got interested. So I began to think, well, what will they be designing? What will good design mean? Who gets to decide? And what will designers be doing if engineers and biologists are now designers? And that's kind of how I began to get interested in synthetic biology, because there wasn't really a definition for design. So synthetic biologists, they say they want to make fuel, they want to make new kinds of materials, they want to make medicines, they want to make kind of unknown other things. And in a way you suddenly have this whole kind of space opened up where design can get involved. But at the same time, what was exciting for me, and I think still is really exciting, is that we kind of get to define what design means in that space. So what does it mean to design a living thing? I don't know the answer. I think it's different to what's come before. And are we just sort of designing materials that are living, or are they dead, or are you using biology as a manufacturing kind of factory to make stuff that I think there aren't any clear sort of answers, and that's what's really exciting for designers, is that it is a space to actually explore these questions that comes back to actually, well, what is it to design stuff? And what is it to be kind of transforming matter into new things? And for me, that gets down to the question of what is design. And that's why it's kind of been such an interesting space to explore. You don't need to engineer something to be able to use biology. But the actual kind of synthetic biology, this sort of engineering stuff, is still complex. So the dream of it being kind of easy to do and anyone would be able to do it hasn't quite materialized. Biology is complex. It does all this stuff that other materials don't do, like it lives and it dies and it reproduces and it evolves, and that also kind of opens up all sorts of interesting spaces for kind of thinking about how you design something or design with something. So the biology becomes a co-author in a way. The really complex stuff is still happening in kind of the world's best laboratories, and it's still really quite difficult to do. But I think that's also where it's interesting, saying, well, we're not replacing scientists and engineers as designers. How do we plug into that system? And what kinds of roles are there for us to work with scientists and engineers to think about what they might design? And that's kind of also a new space. So rather than training designers to be coders or DNA coders, we say, well, what role do we see for design in these spaces? And I think there's a variety of roles, from kind of more traditional industrial design, sort of coming up with concepts and product ideas, to these more kind of strange roles like I enjoy, where you're exploring the ethics of design.
I would say up until this point, I've been working with things that I know less and less about, right? And I have finally hit zero, right? I am finally working, I'm finally working in a field that I effectively knew nothing about when I started. Now I know something. Now I know a little bit. Now I know as much as like a contemporary high schooler. But so I'm working with biologists, and I find it enormously satisfying, because it really gets at the heart of what it means to be a designer, which is that it's not the craft of it, it's not the skill of the CRISPR intervention or the agrobacterial injection or whatever. Those are pieces of it, but what I have is a vision and some goals, and some heuristics around what is better than what, and I have the ability to work with people to whom I can communicate those things effectively, and the output from them is something that I can then work with and refine and revise and so on and so forth. And it is so antithetical to what a designer is supposed to do, which is to know everything about whatever they're working with, right? But it's, maybe the analogy is like, there have been really good film directors who don't know anything about cinematography per se, but they've got a great cinematographer, and it's their ability to communicate with the cinematographer to realize that vision, you know, or a really good editor or whatever, you know, maybe it's more like that. But it's very strange to sort of be feeling around in the dark on this stuff and try to figure out how to be expressive with biology. It's a great adventure, and I would say the best thing about it has been it has brought me into contact and collaboration with some of the most fascinating scientists and botanists and geneticists who have definitely never worked in the way that I work before. You know, they're either looking to answer this very specific thing of how to make a tobacco plant a little bit more resilient, or they're looking, you know, at some greater vision of how to of soil restoration, or, you know, whatever. But the idea of of working the way designers work, of just sort of trying something out and, you know, seeing where it's at and revising it, and what, you know, they often say, like, well, you know, what are your criteria? And I go, you'll know. Like, you'll know. It's a sensibility, right? It's not quantitative, right? But it's a sensibility, and figuring out how to articulate a sensibility in bio is one of the most interesting aspects of it all. Living closer to nature doesn't mean living closer to trees and parks. It means living closer to this weird, invisible world that that we don't have a name for yet, right? Like, and as designers, as artists, I think there's a very important responsibility to allow us to provide the rest of us with an imagination for this world that scientists haven't yet described.